So I'm going to record it because this can be really hard for people. So the first thing is we've looked at the first difference here, and unlike the other day, it's not common. Which means it's not a linear function. Right, because it's not going to go up the same steepness. That's right. So Stephen, did you come up with anything else?
Like the number of people that are there, including you, and then the number of times the number of people that you should answer, one less person.
So you actually found a rule?
Yeah.
So for 30, tell me how your rule works.
So it's 30 years. Okay, so it's 30 times 29
times 29
divided by 2.
Divided by 2. Let's see if it works. So let's plug in 5. It'd be 5 times 4 divided by 2, which is 10. Try for 3. 3 times what, you guys?
2.
2 divided by 2. Good job. How many people? Wait a minute. Raise your hand if you got that rule. Okay. Can you do it algebraically? What's the algebraic rule? What is it, Emily?
N times n minus 1 divided by 2.
Yeah. N times n minus 1 divided by 2. Good job.
It has to be like the quantity.
It has to be the quantity. Well, you could also write it.
Otherwise, you could have 2n minus 1 and then the 2 will cancel out, right?
No. Look at what Jacob's asking you guys. There's another way to write it. It brings up your question about, is this an exponential function? It's not exponential. When I multiply n times n, I get n what? Squared minus n over 2. It's quadratic. So quadratic grows differently than exponential, but it's also not linear. So you were right about that.
So, but then can't you like make a line or like a shape out of that?
I could. If I took the time to plot this, let me bring that in. Oops. What that is. I would get a quadratic shape instead of a line. So if I plotted some of these points, the point 0, 1, and then 2, 1, and then 3, 3, and then 4, 6. I don't know if that would work up here. Let's pause this for all the time. So what we're going to do now is,
So what's the real answer?
the real answer is 30 times 29 divided by 2.
Well, that's not the same thing as n times n minus 1.
No, there's two different things that you missed. I think you missed what they were talking about. The real answer is this, and when you multiply that out, what'd you guys get? 409. Let's check it. So if we do 30 times 29 divided by 2,
It's a lot of handshakes.
435. Did anybody get that? Okay, so guys, do you see? So do you see his method's right? Okay, I need you to listen, so I'm going to wait. Okay, so his method's right. They multiplied wrong. No big deal. So 435. We can double check that. I'm going to just check it one more time. 29 times 30 divided by 2, 435. But Connor, to answer your question, this is the actual answer to the problem.
So then how? So it's just n times.
But this is the rule. And tonight your goal is to come up with the rules in algebraic form. Well, I'm going to try to explain it, so I need you guys to stay with me now. Okay? So watch. I'm going to go to some problems like this one here. This one here. Okay? The first thing that you do is you check first differences. So if I check these, Sky, when you subtract, what do you get?
Oh my god, great mark. 9.
Okay. And then Maddie, how about here?
13.
Okay. And then how about here? What do you think's gonna be?
17.
Why?
By 4.
Because it fit, okay, so let's check. So 9 and 6 make 15. 15 plus 13 make 28. 28 plus 17 does make 45. And if I wanted to figure out the next term, I would add 21. So for those of you guys that don't see that, the red is the first difference. If we look at the second difference, you get 4, 4, 4. So if I add 4 to 21,
Oh, you get 25.
I'm going to have to put 25. That's right, 25. I'm going to add 25 the next time. So 21 and 45 gives me 66, and then I would add 25 more to get the next term.
Oh,
Okay, so first of all, just raise your hand if you guys see the pattern.
I see the pattern, but I don't know how to write it.
I haven't gotten to the writing part.
Sorry.
Gotta let me keep going.
Okay.
Okay, so we're okay with the pattern? So when the first difference is common, it's linear. It's an order 1 polynomial. When the second difference is common, it's called a quadratic because your exponent is squared. So what you do is you take every problem like this and you look to see if you have a common first difference. If you have a common first difference, you do what you did the night before. You make a line equation. If you don't have a common first difference, you look for a common second difference. And then if it's a common second difference, you're going to look for a quadratic. And what you know is that a quadratic could be two things multiplied together. A multiplying pattern. Okay? So watch. Now, all of this stuff, I'm going to start crossing out because it ends up, there'll be so many numbers here that it gets a little confusing. Okay? So, the fact that I've done this, I've used this, I'm done with these, I'm done with these, I'm going to ignore them now. They have served their purpose. I now know I'm looking for a multiplying pattern, I'm looking for a quadratic. That's the goal. Okay? So now what I'm going to do is I'm going to look, Luke, I need you to hang on for a minute. I'm going to go back to my numbers and see if I can find a multiplying pattern. Like, what's a way, 2 factors that multiply to give me 6? Just give me an example. Alyssa. 2 numbers that multiply to give you 6. 3 and multiply to give you 6. I just didn't hear you. 2 times 3. Another way would be
4 times 2. Or I mean, 1 times
1 times 6, right?
Right.
Connor, just be quiet.
9.
Okay. No, let's go through that. Now think of numbers of ways to get 15. 3 and 5. Okay. Give me a minute, guys.
Oh, number's 3.
Wait. Or 15 and 1. Okay. 4. Watch. 4 times 7. Okay, now look at, guys. Look at, if I take a highlighter out, do you see any patterns here?
Oh, man, there's another one.
5 times
5
9.
times 9, and then it'll go.
Okay, so with that, if I went 2, 3, 4, I would hope that 5 would be here, right?
Yeah, and then odds.
Okay, so now if I take a different color, 3, 5, 7, 9, right? 9. So hang in here for a minute. So I'm going to put the patterns over here that correspond to the colors there. The numbers circled in pink, that's a linear pattern. Watch, this is a linear pattern. So I said I was going to write all over this. When I go from, well, let me do a little bit of erasing here.
We have to do that for every single one.
Just wait. Just wait. So now watch. When I go from 2 to 3 to 4 to 5, it goes up by 1, so I do 1 N. No, so now you're doing a linear pattern like last night for each pair. Okay, so hold on. So it goes up by 1, right?
Right.
So I'm going to test it. What's 1 times 2?
2.
But I want to get a 3. So I have to add 1. Let's do it again. Look at these ones. 3 to 5 to 7 to 9. What do these go up by? 2. So this goes up by 2n. Test it. What's 2 times 4? 8. But I want a 9, right? So I have to add a 1. So my quadratic, this is my answer. And I'm going to check it. I'm going to check it with the number of 5. I'm going to do 5 plus 1 times 2 times 5 plus 1. Just, let's check it. Let's check it. What's 5 plus 1? 6. What's 2 times 5 plus 1? 11. What's 6 times 11? Okay.
Wait till we have to do this for every
Let's try another one.
this morning or what? That's weird. Like, if I
That's
get like
not a great one to try.
I'm like-
Let me make one up here. Okay, so let's do a new problem. So we're going to do all the same steps. So we're going to calculate the first difference. And that's 6. And then 8. And then 10. Does that make sense? So this would be like your term. And maybe they'll say your value. Okay, and over here, you want to kind of find a rule for the nth term. What's the rule? Okay, that's the goal. So once you have a first difference that's not common, we know it's not linear, so we have to take a second difference. So the second difference is common, right? It's 2. So it's a constant second difference. That tells us it's a quadratic. Which means, because of that, we're going to have a multiplying pattern. We're going to have 2 things multiplied here. Okay?
Okay, so that's a quadrant. That's how you got 2 parentheses.
That's how I got 2 different parentheses. Okay, so you're going to have a multiplying pattern. Okay, so then you have to, so then you're done with this. This stuff served its purpose. It's done. So you just kind of ignore it. I crossed it out. Now you go back to your original values and you look for a multiplying pattern. Like 2 ways to get 4. It's 1 times 4. Oops, let's put a pin there. So 2 ways to get 4. I could do 1 times 4, right?
Yeah.
Or I could do 2 times 2. What are ways to get 10? 2 times 5. So before you write all the different ways, see if you think there's a pattern beginning already. Yeah, right? What's that pattern? What do you see? 2. You see?
Let's use the same.
Okay, I see a different pattern. So let's go one more. So what about 18? Think of a way to get 18. Here. So, yeah, so I'm going to say, look at 6 times 3 for me, or 3 times 6. Okay. So if you do that, and I took a highlighter, and I just did a little bit of coloring here.
Oh, okay, the first one.
The first one. What do you think I'm going to put here?
It's gonna be
4 times 7, right? Now look at the other one. 4, 5, 6, 7. You see some patterns?
Yeah.
And they're both linear. So the pink pattern I'm going to write over here, the one in the pink circle, and the other one in the turquoise.
Okay, so each of the parentheses is a different pattern.
Each parenthesis is a different linear pattern, because a linear times a linear is a quadratic. Does that make
Found
sense?
it.
Okay, hang on. So now I'm going to go to those individual ones, right? And I'm going to look, what's the pattern to go from 1 to 2, 2 to 3, 3 to 4? How much am I going up by? I have a common difference of 1. So that means up here I'm going to put a 1 in. Does that make sense?
Yeah.
I got him. Okay.
Color coded my notes.
Okay, it's good to color code.
Okay.
So now I'm going to test it. So I'm going to do 1
sorry, I
times
didn't
2.
get how you got one in.
Do you see how I got the 1 in?
So
So I took my common difference 1. I took this guy right here. Right?
Yeah.
And basically I take that common difference and it becomes my coefficient.
Okay, and there's always going to be an n right next to it.
Right, like y equals mx plus b form, it's the slope. Okay. So now I have to adjust it. So 1 times 2 up here is 2, but I'm trying to get a 2 in this case. Did I get it?
Yeah.
So I don't have to do any adjusting. Let's test it one more time. 1 times 3, because I'm multiplying by
Put it
this.
through twice. both
Yeah,
numbers.
and I don't need to do any adjusting, so this just becomes 1n.
Okay, so oh, so otherwise you do the subtractive thing. So each one's like, you get the 2 different numbers, and so like put it through twice. So
I
that's
put it
two
through
different
twice.
Things.
Right, so now if I did
Okay.
this one, so if I take that pink one, right?
Yeah.
I'm gonna do from 4 to 5, 5 to 6, 6 to 7. That goes up by 1, up by 1.
What class is this?
Geometry, you don't remember doing this? So this one, oops, that one there,
I feel so confused.
that becomes my coefficient up here.
Okay.
And now I'm gonna test it with 4, okay? So watch me test it. I'm gonna do 1 times 4. 1 times 4 is 4, but I need to get a 7. I have to add 3. So let's test it one more place. If I test it with 2, 1 times 2 is 2, but now I need to get a 5 plus 3. So my rule is just n from here times n plus 3. Okay. So remember, you're only going to try this for 30 minutes because some of them are a lot harder.
Okay.
So if you
I
aren't
just did the
making
basics.
progress, you just stop and we'll do more tomorrow. Okay?
Wait, am I being recorded?